Keystone Cooperative is the seventh largest agricultural cooperative in the United States. The cooperative grew to such a size over many years, in part due to many mergers and acquisitions that it has gone through. As such, with its growth, Keystone has encountered new challenges, one of them being that many customers have multiple accounts with the cooperative, and there is no easy way to discern which accounts belong to the same individual. The goal of our project this year has been to create a web application which can help identify potential user accounts belonging to the same individual and allow users to record such matches. Keystone already had some data which indicated that a group of accounts belonged to the same user. However, it did not extend to all of the users. Thus, this data combined with the data associated with each individual Keystone account can be leveraged to develop a method for identifying potential account matches. The solution for this was to develop a logistic model which could be implemented in the web app. It's important to note that this logistic model will operate on a per account basis, meaning it analyzes and makes predictions for one account at a time. Logistic regression works by receiving multiple inputs and returning a classification based upon the given inputs. In our case, there are only two classifications for a pair of accounts, match or non-match. From the data which the project team was provided, it seemed that 4 points of data would be most useful in determining whether a pair of accounts belong to the same user. The team considered how similar names were, how similar addresses were, the distance between accounts, and the number of invoices which the accounts shared. Before any model could be trained, however, the team would also have to generate a list of account pairs which were not matches. Our approach has been to generate roughly the same amount of non-matching account pairs as matching account pairs to reduce bias in the model, and the model does not favor one classification over another. After the first iteration of developing the logistic model, the team had promising results. The logistic model had achieved 91.3% accuracy, being trained on around 6,000 data points and tested on upon around 2,000 data points. Notably, the coefficient which pertained to the distance between accounts was very small but positive. A positive coefficient for the distance between accounts indicated that as the distance between accounts grew, so did the likelihood that the accounts were related, although very minimally due to the very small value of the coefficient. As such, for the second iteration of developing the logistic model, the team opted to ignore the distance between accounts as a feature of the data. The team also opted to treat invoice splits as categorical data, not numerical data, as had been done with the first logistic model. The result of such changes was that the model was hardly impacted at all. The coefficient for each feature of data were very similar, and the model was still achieving a 91.3% accuracy. Thank you.